Welcome back. So in this lecture, let's talk about the sorting techniques. The first sorting technique that we're gonna discuss in our course is bubble sort. Okay. So bubble sort. I think I have to increase the thickness of my pen. All right. So bubble sort, and bubble sort is way easier, guys, but it is somewhat complicated. I mean, somewhat you know takes more time. Okay, to execute, but it is way easier. Takes more time, of course, and you will understand the statement and by the time I would have explained this bubble sort, right? So takes more time. Okay, so let's say this is my array. Let me take an array, unsorted array. Let's say 25, 12, 10, 5, and 27. So unsorted element. Okay, and we have one more element, say 36. Okay, so this array is unsorted. Okay, this array is unsorted. Okay, so how bubble sort works to sort this array? So one more thing I want to insist here is, for bubble sort you have to choose two consecutive elements. Choose two consecutive elements and compare them. That's the main idea of this algorithm. Choose the two consecutive elements and compare them. All right, that's the main idea of this algorithm, right? And this one line would help you. Okay, right, this one line would help you. Yeah, let me go by this line. So let me choose 25 and 12. That's my first two elements, right? You can clearly see that 25 is greater than 12. So a swapping should be made here. That's the idea. Okay, if the first element is greater than the next element, then a swapping should be made. Okay, I'm sorting this in ascending order, right? Then 12 should come first, then only 25. So a sorting should be made. So what I'm doing here is I'm swapping it. I'm swapping 12 and 25. All right, so after that, what will be my array? Sorry, something it goes like that. Okay, right. So what will be my array after this step? I'll get my array like this: 12, 25, then 10, then 5, then 27, 36. You can see the first two elements are sorted, right? And after that, I have to choose the next two element, right? So next two element is 25 and 10, and you can see 25 is greater than 10. All right, so what I'm going to do is I'm going to swap again. This 25 and 10 should be swapped again, right? So 12, 10, 25, 5, 27, 36. This is my condition. So I'm just sorted 25 and 10, right? And what I have to do here is, now I have to choose the next two elements, that is 25 and 5. So 25 and 5, if I compare, and obviously it's greater than 5, so I'm going to swap that again. 12, 10, 5, 25. So 25, 5 becomes 525 if that is swapped, and 27, 36, right? And after that, I'm going to choose these two elements now. So you have to choose two consecutive elements. First I have to choose 12 and that, and 12 and 25, then you should go like that, 25 and 27, right? And 25 is lesser than 27 actually, right? It is not greater than 27, it's lesser than 27. So it is already sorted, you can see. Okay, uh, 27 should come after 25 only, right? So this is sorted in ascending order, right? So there is no swapping need to be done here, right? You can leave that, and you can go for the next step. Okay, so no swapping done. You are getting the same array, right? After that, you have to choose the last two elements, 27 and 36. So 27 is actually lesser than 36 only, right? So in this case also it is sorted, right? So there is no need to swap the elements, right? And this is all about the first iteration, right? In the first iteration you are making these changes. In the second iteration you have to repeat the same steps, because you can see the array is not sorted yet, right? You can see here somewhat, you can see that. Okay, so it has to be sorted, so you have to go for another iteration, right? So in another iteration the idea is very similar. You have to compare the first two elements. So here it is 12 greater than 10, so swap it, right? So what you are getting here is 12 and 10 swapped. So 10 should come first, then 12, right? So 25, 27, then 36, right? and after that you have to choose the next two elements, and okay, so and so you have to go like that. Okay, and it will take a long time, guys. I agree with you, right? It will take a long time, and the final result would be, so you have to choose the 12 and 5, and you can swap that here, right? Then it will become what? 10, 5, 12, 25, 27, 36, right? Again, you have to check compare swap. No, there is no swapping here because this and all sorted. So you just have to compare it, compare these two, and no need to be sorted because they are already in sorted order, right? After that you have to go for the third iteration because you can see the array is not at all sorted, right? So you have to go for the third iteration. And in the third iteration, what you can do here is, again you have to select the first two element, right? So if you select the first two element, of course 10 is obviously greater than 5, so what you can write is 5, 10, 12, 25, 27 and 36, right? So this is my final result, right? After that, even if I search the array, there is no need for us to sort because this is now sorted. So sorted successfully. So it will take a long time, guys. Okay, so you can see the length of the algorithm here. So first iteration you have to check for all the elements. So why it is called bubble sort, why it is called bubble sort? Because we are forming a bubble between two elements. Okay, we are forming bubbles between two elements. That is why this is called as bubble sort. All right. So the idea is that, right, form a bubble and check, compare the element, and if the element is greater, then swap it. That's it. Swap the elements, right? So of course the time complexity for this algorithm is, the worst case time complexity would be O of n square. Why it is n square? Basically the idea here is, you have two loops here. That's why it is n square, two loops, and they are nested. Okay, one loop is for the outer loop, which is I, and the inner loop, which is j. Okay, inner loop will take care of bubbling and swapping, and outer loop will take care of the iteration. For example, sorry, this has to be kept here, right? For example, you can see we have gone through the first iteration. Here we have started the second iteration, and we have started comparing it again. And we have started the third iteration. We have started comparing it from the first again. So this third, second, and first, it is controlled by the outer loop, which is I. Okay, controls the number of iterations. Okay, and the inner loop will control the bubbling and swapping, right? So inner loop will start from the first element, always the, sorry, okay, so yeah, let me keep it here. The inner loop will start from the first element, and it will traverse to the last element, right? It will form bubbles, and it will swap the elements, right? And that is taken care by inner loop. Okay, so inner loop will take care of bubbling and swapping. Okay, bubbling, comparing, and swapping the element if want. Or while comparison, if you got the first element is greater than the next element, means you have to swap it, right? So since you are using the nested loops, the worst case time complexity is O n square, right? And the best case would be O of n. Of course, it is O n square only. If you use some special condition, then you can stop it in O of n. Okay, special condition, then you can stop it in O of n, and we'll see that in the C program. All right. So that's all about bubble sort, guys. See you all in the next lecture. Thanks a lot. Hello everyone. In the previous video, we have seen the working of the bubble sorting algorithm. Okay, bubble sort algorithm. Here we are going to implement the bubble sort algorithm, right? So let me call it as implementation of bubble sort algorithm. Implementation bubble sort algorithm, right? So first, to perform bubble sort, I'll be having a separate function to perform bubble sort. Okay. So first I will write the code for swapping, because anyway it is based on swappings only, right? Swappings and comparison. So I have to make a code for swapping, this for swapping the elements, okay? And this is going to be based on the the pointers concept, because for swapping I'm going to define a separate function. I have to call the function by reference only. If I simply call the function by the values, then only in this function the values will be swapped. In the original function, that is in the bubble sort function, the values will not be swapped. So here I'll be having two pointers. Let me call it x and y. I'm having two pointers here. Okay, so I'm getting two pointers here. This function is basically a void function. I'm not going to return anything. I simply have to swap the elements, that's it. So let me say I'll be having one more variable called temp. Okay, so I'm going to use swapping with three variables. Okay, so temp, then I have to say the value at x. So whatever be the value at x, that will be stored in temp variable. Then whatever be the value at whatever be the value at y, that should be stored in the value at x. Okay, whatever be the value at y, that should be stored in this value at x. Okay, that should be stored in the x. Then whatever be the value at temp, that should become the value of y. Okay, whatever is the value of temp, that should become the value of y. Temp actually holds the value of x, so value of x should be assigned to value of y, and here value of y is assigned to value of x. So we are now done with the swapping algorithm, right? So this algorithm will definitely work. All right. Now we will have one more function which I will name it as bubbleSort. Okay, which I will call bubbleSort, and we will be having the array first of all. Okay, we will get the array and we will get the size of the array. So these are the two basic parameters that we have to get, because anyway we will be sorting the array only. All right, we will definitely be sorting the array. We won't be you know searching for any element like in search algorithms, right? We'll just be sorting the array, so there is no need to get anything else other than the array. Okay, size also if you want you can get, or you can compute in the function itself. Okay, it doesn't matter, right? So I will be having two pointer variables. Okay, we know that we have discussed in the previous video, for ith and jth element. So we have to make comparisons between those two, right? We have to make comparisons between two elements at time. So for that we need two pointers. That's going to be ing, right? And I'll let me have a variable called isSwapped. It's going to be a Boolean variable. So let me call it isSwapped, which will inform us whether all the elements are swapped or not. Okay, why do we need this? Because if all the elements in a particular pass are not swapped, if none of the elements are swapped, okay, none of the elements are swapped, it means that the array is sorted, right? None of the elements are swapped. In that case, what we have to do is we have to make it false. Okay, so none of the elements are false. So when none of the elements are swapped, we have to make it false. Okay, in this case exactly, the third pass, no swap has been happening here. So we have to make the swapped variable to be false here. All right, otherwise we will keep it true. Okay, all right. Okay, whenever we perform a swap, we will change it to true. Okay, that's it. Then we have to start writing a loop. So the outer loop will go from I equal to 0 up to size minus 1, right? Up to size minus 1 I plus plus, right? The inner loop should go from j equal to 0, j less than size minus 1 minus I. Okay, minus I plus j plus plus. Why minus I? Okay, size minus 1 is perfectly fine, but why minus I? This is because of the reason that in each pass one element will be sorted. Please try to understand that if you have completely randomized element, then the general procedure is in each pass one element will be sorted. After the end of first pass, 9 will be sorted, right? So it is enough for the next pass if we check only at the first four elements. Okay, so it's gonna be j minus I minus 1. Okay, I mean n minus I minus 1. Okay, n minus, if n is equal to 5 means, so 5 minus I is now 1, right? At the first pass means I is 1. At the second pass I is 1. First pass I is 0, right? So for second pass I is 1. So total number of elements in array is n. At the second pass I becomes 1. I will again have 1. So 5 minus 1 will become 3. So I will start from 0. I'll go only up to 3, right? I'll go only up to 3. All right. I won't check the last element. Okay, before the second pass, and after the second pass also, I will ignore I will start from 0. During the third pass, I will start from 0. I'll go up to 2 only. Because after the second pass, I know that the last two elements are sorted. The last two elements are sorted. So to keep track of that, we have to subtract I, right? We have to subtract I. Alright. And here, the outside of the loop, I have to say is swapped equal to false. Okay. So no swapping has done outside the loop, right? No swapping has done outside the loop. But inside the loop, if there is any swap, so I will call the swap function. All right. Before that, I have to write a condition, right? So let me say if array of we know the condition. I have already explained the condition. No doubts about it. If array of j is greater than array of j plus 1, I can do like this. Okay, I can. So because this I will keep track of the number of passes. J only is going from j, starting from 0, it goes up to I only, right? So here I could call, here I could say that, here I could say that, I'll add a new page, 2 3 6 5 9. If these are my elements, here I could simply say this is j and this is j plus 1, right? Next element is j plus 1, so I can simply compare these two like this. Okay, again j is incremented, means this will be j and this will be j plus 1, right? This will be j plus 1. Okay, so I can simply compare two elements like this, because I will keep track of the number of passes I'm making, right? Number of passes and I am making, right? So this will make sense, right? This is making sense. So here, if array of j is greater than the array of j plus 1, that is, the current element is actually greater than the next element. In that case, I have to swap, okay? Because the current element has to be smaller than the next element. That is exactly the sorted order, right? So I have to swap it in that case, okay? So here I have to pass the uh, address of array of j. So we have to pass the address only, because here we are getting some pointers which will store address only, right? So array of j, then address of array of j plus 1, right? Address of array of j plus 1. All right. So since we have made a swap, we have to make each swapped variable to be true here. Okay, each swapped variable to be true, right? All right. And finally, after this inner loop is done, after this inner loop we have to check, okay, we have to check whether this swapped equal to true or not. Okay, so if it is, I mean, false or not. If it is equal to false, then it means that it remains in false only. You just try to understand it logically. It is initially false. Inside this loop, if if we are making swaps, we are making it true. If the current element is greater than the next element, we are making swaps. If we are making swaps, we are making it true. What if the array is sorted? If the array is sorted, this condition will not become true anymore. The array is completely sorted means this condition will not become true anymore. So swapped will not become true. It will remain in false only. Okay, it will remain in false only. So I am checking whether it is remaining in false. If it is remaining in false, then it means that I have not done a single swap. Okay, I have not done a single swap. That means the array is sorted. So I can simply break the outer loop. Okay, since I am writing it outside the inner loop, I can simply break the outer loop, which means that the array is now sorted. Okay, so this is gonna be my bubble sort function. I hope this is clear. Now I will write my main function. Okay, here first of all, I'll be having my array here. So let me say my array is 2, 4, 3, 7, 6, 9. All right, so these are my array elements, okay, which obviously they are not sorted. Okay, they are not sorted. Now the size of the array is, let me declare it like this. The size of the array is gonna be, all right, the size of the array is what, 6, right? Let me have it 6. Okay, anyway, you can use the way which I told you in the searching algorithms to find the size of the array, but let me simply declare it 6 here, time being, right? So now I will call the bubble sort function. Here I can pass the array as well as the size. Those two parameters are necessary here, right? That's it. After that, I will simply print the array element by element. I will print the array. To print the array, what I have to do? I have to go for a loop, right? So let me say int I. Let me have one for loop to print the array. So it will start from 0. It will basically go up to size minus 1, and it will say I plus plus. So during each iteration, I can print a single element of the array, right? So I could say rough I hope this is making sense. So the idea is very simple. based on a single condition. If the current element is greater than the next element, swap it. Okay, and do it again until the array is sorted. Very simple algorithm. Swap it and do it again until the array is sorted. Once the array is sorted, is swapped is false, so you break the loop. Okay, you stop swapping. Okay, you stop comparing the elements. Okay, you need not compare the elements anymore, the array is sorted, right? So very simple algorithm. Okay, so now let me check for syntactical errors. Yes, there is one syntactical error. It must be here, right? Size -1 it has to be. Anything else? One more syntactical errors. So here I need not put like this while calling the function. I can simply say r. Okay. Right. While printing, what we can make here is we have made size -1. We have made it actually less than size -1. So it will not go up to the last element. We have made it less than size -1, right? So it will not go up to the last element. So what we can say is we can simply make it size. That will make sense, right? Yes, now 9 is there, right? Now 9 is getting printed. Or else you can even make like this, I less than or equal to size -1. This will work. It will go up to the last element, right? Size -1 is our last element. So if you put equal to, it will go up to the last element. But if you don't put this equal to sign, it will stop at size -2. That is the element which is present before the last element, right? Okay, I hope you got the mistake that I have done here. Thanks a lot.